So welcome to Pinoy Matinik. So our next topic is all about families of curves. So families of curves, it is represented by an equation involving a parameter as well as one or both of the coordinates of a point in a plane. So it is also one curve corresponds to each value of the parameter. Let's take note that it is also obtained by eliminating arbitrary constants but leaving the parameters. So usually it is done through differentiation. It is done through differentiation of equation of relation. So now let's go to our first example to solve for families of curves. So our first example is straight lines through the origin. So we know that we give a solution. We know that straight lines, we can use the formula for 2 point form slope. So we know that the equation of that is equivalent to y minus y sub 1 is equal to m, sorry, I'll just delete it, equals to equal to m multiplied by x minus x sub 1. Because it is in origin, so automatic our y sub 1 and x sub 1 is equivalent to 0 comma 0. So I will just substitute y sub 1 and then x sub 1. So we will have y minus 0 is equal to m multiplied by x minus 0. So we will have y is equal to m multiplied by x. As you can see, we only have one arbitrary constant, which is m, which is this m. So now let's take the derivative. So we will have y prime is equal to the derivative of mx. So the derivative of mx will become m multiplied by 1. So because the derivative of x is equal to 1. So we will have y prime is equal to m. So by using this, we will substitute y prime into our m, into our equation, which is this. So we will have y is equal to the value of m, which is y prime multiplied by x. We know that y prime is also equivalent to dy over dx. So we will have y is equal to dy over dx multiplied by x. By multiplying the equation by uh multiplying two equation by dx, so we will have y dx is equal to x dy. So our answer is equivalent to y dx minus x dy is equal to 0. So our next problem is this. Straight lines through the fixed point h comma k where h and k not to be eliminated. So also we will use the 2 point slope form. So we have y minus y sub 1 is equal to m multiplied by x minus x sub 1. As you can see, we are given that it is the line passes through h comma k. So we will substitute this one for x sub 1 and then we will substitute this one for y sub 1. So we will have y minus y sub 1, which is equivalent to k, is equal to m multiplied by x minus x sub 1 is, which is h, equivalent to h. So taking the derivative, as we all know, k and h are not to be eliminated. So we will only eliminate m. So we will take only the first derivative. So we will have y minus, sorry. So we will have y prime. I'll just delete it first. So we will have the taking the derivative. So with respect to x, So taking the derivative with respect to x, so we will have y prime minus, this will become 0. So we will have y prime is equal to m multiplied by the derivative of this. So we will have the derivative of x minus h is also equivalent to 1, because the derivative of x is 1 minus, and then the derivative of h is equals to 0. So we will have y prime is equal to m. So taking this, we will substitute this one to our equation. In this equation, y minus k is equal to m multiplied by x minus h. So by this, we will substitute y prime into our m. So we will have y minus k is equal to y prime multiplied by x minus h. We know that y prime is equivalent to dy over dx. So I'll just change y prime with dy over dx. So we'll have y minus k is equal to dy over dx multiplied by x minus h. And then multiplying both sides of the equation by dx. So we will have y minus k quantity dx minus equal to x minus h quantity dy. And then transposing this one to the left side, so we will have y minus k dx minus quantity x minus h dy is equal to 0. And that's our answer. So now let's go to our third problem. So our third problem is circles with center at the origin. So in order to solve or make our equation, we have to draw it first. So I'll draw a Cartesian plane. So circles with center at the origin. So this is the origin. So I'll make a circle, and then we all know that the center uh, of the circle is h comma k, because it is in origin. Therefore, our h comma k will become 0 comma 0. And then we all know that the formula for circle is this: x minus h squared plus y minus k squared is equal to r squared. We know that our value of h and k is equivalent to 0. So we will substitute 0. So we will have x minus 0 squared plus y minus 0 squared is equals to r squared. Then simplifying further, we will have x squared plus y squared is equals to r squared. As you can see, we only have uh, one arbitrary constant. So we will only take the first derivative. So differentiating both sides with respect to x. So we will have 2x plus 2y, and then don't forget when you differentiate y. So we will have, when you differentiate y, we always put y prime is equal to 0. So now, as you can see, both both the first and the second term is divisible by 2. So multiplying both sides by 1/2, so we will have x plus y prime is equal to 0. We know that y prime is equal to dy over dx. So I will substitute dy over dx into our y prime. So we will have x plus y multiply by dy over dx is equal to 0. Multiplying both sides of the equation by dx will come up with this answer: x dx plus y dy is equal to 0. And that's the answer. Now let's go to our fourth example. Our fourth example is circles with center on the x-axis. So it's like I tell you, like I said a while ago, we should draw the problem first. So I have this. So circles with center on the x-axis. So draw a circle on the x-axis. So you can see, for example, this one. Sorry for my drawing. So as you can see, we have h comma k. Then this is also h comma k. I'll sub like this. And h3 and k sub 3. Actually, circles with center on the x-axis. As you can see in our problem, we don't have the value of y in our center. So, meaning, the value of k is equivalent to 0. As you can see, we don't have a value of k here, we don't have the value of k here, and we don't have a value of k here. So, therefore, the our equation is our working equation is this. So, I'll just x minus h squared plus y minus k squared is equals to r squared. We know that k is equivalent to 0, right? So I'll just put 0. So we will have x minus h squared plus y squared is equal to r squared. As you can see, we have two arbitrary constants, which is h and and r. So by this, we have to take two derivatives. That's the first derivative and the second derivative. So differentiating both sides of the equation with respect to x, we will have two quantity x minus h plus the derivative of this one is 2y, and then because this is y, so we will have y prime is equal to 0. As you can see, both the first term and the second term is divisible by 2. So we could multiply both side of the equation by 1/2. So we will turn it, it will turn to this x minus h plus 2y y prime is equal to 0. As you can see, to eliminate h, we will have to take the second derivative. So multiply by taking the second derivative, we will have we will have 1 for the derivative of x minus 0 for the derivative of h plus 2 quantity. As you can see, this one, we will use product rule. We know that the derivative of u times b is equivalent to v du plus u dv, right? So by taking the derivative of this one using product rule, we will have y prime multiplied by y prime plus y quantity multiplied by y double prime is equals to 0. Further simplifying our equation, we will have 1 plus 2 quantity y prime squared plus y double prime multiplied by y is equals to 0. And that's our answer. Now let's go to our last problem. So parabolas with vertex and focus on the x-axis. So it's like I tell you, we have to draw it first. So parabolas with vertex and focus on the x-axis. So meaning our vertex, for example, this is our vertex and this is going to be our focus. So by this, we can see that the parabola is like this. So we know that the formula for parabola that that's open to the right is the formula is this: y minus k squared is equal to 4a quantity x minus h squared, x minus h, sorry, x minus h. As you can see, we don't have a value of y here for the vertex and focus, meaning this will cancel out, so we will have this: y squared is equal to 4a quantity x minus h. As you can see, we have two arbitrary constant, which is a and h. So we will take two derivatives up to second derivative. So by differentiating both sides of the equation with respect to x, so we will have the derivative of y squared is equivalent to 2y, and then because it's y, so we will have y prime is equal to 4. The derivative, as you can see, both of this is we can use product rule. So by using product rule, I'll just write the formula. We'll have plus u dv. So by taking the product rule, we will have the derivative of 4a, the derivative of this is equivalent to 0, multiplied by our the second term, which is x minus h, plus copying the first, which is 4a, multiplied by the derivative of second, which is equivalent to 1. So we're simplifying those, so this will become 0. So we will simplify. So we will have 2y prime is equal to 4a. So you can see, dividing both sides of the equation by 2, this will cancel out. And then this one. So we will have y prime is equal to 2a. As you can see, mm, we still have 2a, so we should take the second derivative. So by taking the second derivative, we will have, as you can see, this is also we will use product rule. So I'll just use another pen. Apologies. So we will have the derivative of y, which is equivalent to y prime, multiplied by y prime, plus plus copy the first, multiply by the derivative of second, which is y. The derivative of this is y double prime is equal to 0. So as you can see, we will have y double prime times y plus y prime raised to 2 is equals to 0. And that's the answer. Thank you, Pinoy Matinik, and see you on my next video.